Next, let's talk about sway. This is a very commonly reported issue for motorhomes, and it makes sense because they're so tall and top heavy. So what is sway? The coach leans, sways, or rocks in a side-to-side motion. It feels top heavy and unstable. This could be present at only low speed, could be present at high speed, or in both conditions. So if you want to test for low speed sway, a good way is to drive in or out of a driveway at an angle or over speed bumps on just one side of the coach. See if the coach continues to rock back and forth afterward. For high speed, a good way of testing is to change lanes rapidly, as rapidly as you safely can for the conditions, as if you were to avoid something in the road, and or you can drive the coach on a curvy, windy back road. So weight distribution is important in this case. So the more weight up high, the greater the tendency to sway. So if the coach is taller, if you've got solar panels on the roof, you've got heavy items stored up high, all of that is going to increase the tendency of a coach to sway. And this can explain why you could have two of the same chassis coach. One may have quite a bit more of a problem with sway than another. Well, it could just depend on how the coach was built, as well as how it's loaded. So an obvious solution to sway is the anti-sway bar. So these are installed on most coaches and are essentially a spring that gets twisted to reduce the tendency of a coach to lean. So there you can see a graphic. You can see in the front that kind of U-shaped bar there. This here is the anti-sway bar. So you can see as that coach is leaning, that bar is being twisted. This side of the bar is being forced downward, and this side is being forced upward. So the bigger the sway bar, the more resistance it's going to have to that lean. So if you've already got sway bars, you definitely want to check to see if the bushings on those sway bars are properly secured. Here's an example of one that is not properly secured. This is a V8 F53 chassis, one of the new V8 F53s that comes from the factory with 2-inch diameter front and rear anti-sway bars. It's a very healthy size sway bar. However, if your bracket's fallen off and your bushing's just dangling like that, then the sway bar is not doing much, regardless of how big the thing is. There you can see another example of the bracket is still there, but the bushing itself is falling apart, so that sway bar is able to move quite a bit before it actually does anything. And there you can see a little bit of a gap in the end-link bushing on a Freightliner anti-sway bar. So definitely want to make sure is the sway bar that the coach is equipped with properly secured. Also, you want to check, are the end links properly connected? So the picture at right was taken on F53 with the popular cheap handling fix applied. So what the cheap handling fix does is it relocates the end link from this location here to this location. Why would somebody do that? Well, the concept, it does make some sense that by effectively shortening the length of the arm on the end of the sway bar is going to be more difficult to twist. However, in this case, it's putting that end link both at an angle and under stresses that it was not designed to handle. So you can see how the thing bent and eventually broke, and now you have no anti-sway bar functional. So we do not recommend people perform the cheap handling fix, just because we've seen quite a few end links in the field broken on coaches with this fix applied. Another thing to look at is, are the anti-sway bars properly supported? So on the Workhorse P32 chassis, came out in the late 90s and was produced until about 06, 07. What Workhorse did is they widened out the track width on the front of the P32, and you can see this kind of gusset area here. This actually shows where the upper control arm was moved outboard. So they widened out the sway bar. They also made it a larger diameter, but what they did not do is adequately support it. So over here you can see this is the factory sway bar support. All of this black here and this bushing, that's aftermarket, known as a Roadmaster spreader bar. So without all of this here, you've got all of this unsupported length before the bar even bends. So what can happen is the bar instead of just being twisted, it's allowed to flex and bend at this point. So it's not working as effectively as it should, and in quite a few cases can actually break the saddle brackets or saddle bracket bolts. So much better to spread out the support and let the bar work properly. Let it just be acting in twist rather than getting flexed in a way it was not intended to. So then another thing to look at is, are the anti-sway bars adequately sized? Diameter, a little bit of a diameter change does make a big difference. So every 1/8 of an inch you go larger in diameter on an anti-sway bar correlates to about 30% more strength in resisting roll. So it's, yeah, quite a few cases you can go up to a larger diameter sway bar and gain quite a bit in roll resistance. So let's say you go 1/4 of an inch bigger, that's 60% stronger than your factory bar. However, it is important to consider that not every sway bar upgrade is the same. This can be good to look at on like the F53 V10 chassis, for instance, when there are quite a few different sway bars available. So you have to consider, the expense of the bar, both to buy the part as well as ease of installation, durability, how well made is it, the effectiveness of the bar. So that's just based on the dimensions of it. So not only the diameter, but also the length of the moment arms of the bar and how it's supported. Ease of installation if you're doing it yourself, or going back to expense if a shop is going to be doing the work. So here are a couple of examples on the lower GVWR V10 F53. There's a couple of different options available. So these fit the 16 to 18K gross vehicle weight rating F53. The SS107 is a 1 3/4 inch diameter replacement for the factory rear anti-sway bar, which is itself only 1 3/8. So you are gaining 3/8 of an inch diameter compared to the factory bar, and with the same overall dimensions other than the diameter. So that's about a 90% increase in strength versus the factory sway bar. Another option for the 16 to 18K V10 F53 is the auxiliary 1139-146 Roadmaster sway bar. So this one is not quite as large of a diameter of sway bar. It's a 1.5 inches, and it does have slightly longer moment arms, so it's not going to provide quite as much resistance and sway as this design, which has the larger diameter and the shorter moment arms on it. However, you do have the benefit of now having an auxiliary sway bar, so should there ever be a problem with your factory sway bar, now you have this backup unit to still resist sway. And very, very well made kit, got heavy duty end links. So it's going to continue to function well. So it just kind of depends on what you value most. In our experience, the Roadmaster brand of sway bars is really the best option for motorhomes, and then we do have our own custom versions of many of those Roadmaster bars, as well as our exclusive OEM replacement heat-treated bars, such as the SS107. Shock absorbers can also have a key effect on sway control. So it's important to look, are your shocks leaking? Are they worn out? Or are they simply just inadequate for the job? So shocks and sway bars do work together to control rocking. It's also worth noting that shocks mounted very far inboard will be less effective at controlling sway. This is the back of the Sprinter 3500 dually chassis. You can see those shocks are not very far out from the center, from where your drive line is. So when you're having a rocking or a sway issue, the shocks are not being compressed or extended very much to actually resist that sway. And that actually led us to do some custom development with Coney of our own rear adjustable shocks for the Sprinter 3500 chassis. But here you can see a video just showing what low speed sway can look like on the Sprinter chassis. So that's me in both cases. On the right, I am working quite a bit harder and getting quite a bit less movement out of the coach. So the left is totally stock. On the right, we've equipped it with our larger our larger rear sway bar, as well as our custom uh, custom SuperSteer rear shocks by Coney, and then Coney manual adjust front strut. So all of that worked together to really cut down on the rocking that Sprinter experienced. Now, if you have an air ride coach, air spring control can really reduce sway, especially at low speeds. So our SuperSteer motion control units, they slow down the flow of air from side to side in the air system. So that really can cut down on, call it the Walmart wobble, when you're coming in out of a driveway, for instance. It can really improve control. Now, I do want to note that that is different than add-on airbags. So that's talking about reducing sway on coaches that are already equipped from the factory with air suspension. So in our experience, if you've got a coach or a vehicle with leaf springs, just typical steel springs from the factory, adding airbags can be a good option if you have a lot of variation in the load that you're carrying. So this may especially be true on a pickup truck. On a motorhome, however, this is really not as much of a factor. Your load doesn't vary that much compared to the overall weight of the coach. And airbags, they don't really do much to reduce sway on their own if you're adding them to a spring system. In some cases, they can actually increase sway because they can raise the center of gravity without offering their own resistance to sway. So if you're looking to gain ride height on an F53 chassis, for instance, or another leaf spring gas coach, generally we would recommend going with a helper leaf spring or aftermarket spring, just to get the correct support from the spring itself rather than adding on an airbag. And this relates to what I just said with weak springs. So the SuperSpring is a good example of a helper spring where it clamps onto your spring pack and works with your existing springs to just get you the ride height, get you the support that you need. Now, I do want to note that while weak springs can contribute to excessive sway, in some cases, if your suspension is riding on the bump stops, better springs, which raise your ride height, can actually increase sway. So we see this on the front of the GM P32 chassis, where from the factory, they actually used an airbag within the coil spring. So the coil springs themselves were not strong enough to support the weight, so they added airbags within the coils. A lot of times those airbags were not maintained at the proper pressure. The coils pinched the bag blows out, and now the front of the coach is riding basically on the bump stops. So there you can see that in this case there's not a lot of travel left before it contacts the bump stops. We have our own line of aftermarket coil springs, which we actually match to the weight of the coach. You can see there how that's restored quite a bit of ride height between the bump stop and the coach there. But in this case now, since you've added so much travel to your suspension, you may actually have increased sway, because before that bump stop was limiting how far the coach could actually move in one direction. If it's basically riding on the bump stops, then your suspension is fairly rigid, so you may actually gain more sway by restoring it to the correct ride height. So in that case, we would recommend you look at your anti-sway bar sizing, your shock absorbers, make sure that you're doing what you need to do on the suspension now that you've gotten your suspension travel back to control that sway. Other helper spring options, such as Sumo springs, can also be effective at reducing sway and improving stability, especially when the softest ride is not a priority. So if you wanted to do just one upgrade, maybe you didn't want to do shocks or sway bars, Sumo springs can be a good option to give you some benefit without getting too involved budget-wise.